founder of Blocks, an entrepreneur in the blue economy. The blue economy is a guiding line, as you will see in the rest of the presentation. Blue economy, first, of course, of the marine ecosystems, but also of the blue economy by Mr. Blue Economy himself, Gunter Pauli. And one of the guidelines is then also the blue economy, where nature, where waste does not exist and everyone has a job. So that is the main goal. This is me in my little studio in Rotterdam. I'm based in Blue City. For those of you who don't know, that it used to be a subtropical swimming pool, but now it's sort of an example city of the circular economy, where we try to really not only do green, but also work towards economical viability and to create impact, not only by green initiatives, but also that are sustainable in economic sense. And we do that also through collaboration with each other. So as a certain city, we seek each other's collaboration. My background is industrial design engineering, turning entrepreneur into Seaweed, so that's my role in the system. I'm the animal designer maker, and I'm also curious to find out what other species we have in the room here. As you will learn, nature remains throughout all my activities a big inspiration and guideline. So this is a little bit of Blue City. Well, this is not my space. I'm directly below the fundaments of the basin of what used to be the swimming pool, but I'm happy to be here and to try to also build together with others a more or bluer economy. So first of all, before I start about how I came to work with Seaweed as a designer, and what are the current projects, and how do I see that with the company? First of all, design. We're here to double nature. So what is a designer doing within that community? So I will share just a bit of my views on design first, so you will probably have a better context and understanding of the way I work and how Blocks is working as a team. First of all, I think the key skill of a designer is to materialize things that are in essence maybe still abstract, thoughts, ideas, concepts. So materialization of concepts that has something to do with making things tangible, give them shape, color, weight. It can be an experience, so it doesn't have to be physical, but it can also be visual or sensory in taste. But it always has to do with making things tangible in one way or the other. The second point is that, as a designer, I used to teach also for 8 years to design engineers, but also in my practice, I noticed that we constantly make decisions. All the things that you see around you, at some point, somebody has made a decision about it, about the way it looks, but also with what kind of materials it's made, where they are sourced, and what happens after life. So the impact of decisions made at a drawing table are relatively high, and that also brings responsibility. The third point is that that's also the key phrase within the company. We are humans and we create systems. We create waste. We have created wasteful systems. So if we're able to create systems with waste, then we should also be able to design or redesign systems without waste. And that is a firm belief and also a hopeful one, I think. So that is a key phrase that we use almost daily. And the fourth point is that there's always... or there's not always, but there is sometimes a tension between what's technologically feasible and possible and what society embraces. As an example, the electric car already existed 100 years ago, but at what point does society or humans, consumers, we all are ready to adopt new technology or a solution? I think where designers, a key design principle for a long time was human-centered design. I think we're moving slowly towards life-centered design. So we do not put humans necessarily in the center point of our attention, but still designing applications with available technology, with what's available resources is what a designer can do. Applications that are embraced by people. When they embrace something, then you're able to create impact. And the final one is also a question also for designers. We think in solutions. We like to talk about, oh, there was a design problem and we have this idea, we have the solution. But actually, when you're looking at challenges like climate change, or crisis, or how you would call it, or political movements in the world, as the introduction was mentioned also, food systems, the challenges that we face, cannot be answered with one solution. So whatever solution we think of, it will never be perfect and it will never solve the whole challenge. But as a professor once said, so we cannot think in create solutions as designers or as humans or as people. But what we can do is create high quality interventions. And I think that is something I can work with, and it is something we can all work with. And if there are multiple series and a variety of places of high quality interventions and you add them up, then that in its total might be a solution, and then we might be able to reverse climate change, for example. So these are the starting points that I wanted to share with you about how I see my practice of design. And I also would like to think back to how then did you came to seaweed then, and food in general. I look back at my agenda today, and actually on November 7, so almost 3 years ago, around 2017, I was talking to my leading lecturer of a research group I was also involved in. And she asked me, so if you would have to draw your dream, what would it be? And I was already very interested in food and the challenges of the food system that we face in terms of hunger on one side, unhealthy diets on the other side. Do we have enough food in 2050 for everyone? How do we do that with land scarcity, water scarcity? So a lot of different challenges, so also a complex problem. And this is the drawing or the little sketch that I made then. And it actually reflected what I thought, what might be the role of the designer in maybe the transition towards a more circular food system. So what we have been seeing is that we move from a very linear food chain to trying to create a more circular food chain. So can we make use of residual streams or waste streams, and can we reuse them within the food chain or one of our partners within the food chain? And especially in the food logistics and the food chain, it's difficult actually, because once something is considered a waste stream, you cannot actually re-enter it in the food system. So then if we take it one step further and we look at nature, how then the food system works is that we actually work with food webs. And food webs are nothing more than interconnected food chains. So different species and multiple food chains collaborate together, and we create a network that is in its total zero waste. And that was a starting point for our design research question. So can we design and prototype, so actually create something tangible, a new nature-inspired zero-waste food network based on the natural principles, design principles, and maybe possibly learn from that and translate these learnings to other existing food systems or maybe even completely other systems. The key idea is that we take a natural resource and we try to form a network of organizations that all have their role in the total system. So you can be a producer or a primary consumer, a scavenger or a decomposer, or maybe you're the sun. Everyone is needed, and as long as all key elements are represented in that local system, because the food webs, the frog also doesn't travel to the States to catch its fly. It's very locally attuned. It's interconnected. Relationships can be flexible. The mouse can be eaten by the eagle, but also by another animal. So in that sense, it's not a rigid chain, but in time, the roles and the relations can be flexible and you can create an adaptive system. So that was the starting point. So, okay, that was the abstract idea. So now how can we materialize this? So I had to look for a source food, and I totally fell in love with seaweed for multiple reasons. On the right, you see an image of a research by Jurgilovic and others of 2016. And the key points here are what are then the 3 elements that we need to look at if we want to move towards a circular food system. So the 3 key points are food production, food consumption, and food surplus and waste management. So what do we eat? So our diet is very important. We all know that meat has another impact than, for example, seaweed, but also in terms of health, human health, and abundance of resources, what are future-proof food sources? So what do we eat? Then also, of course, how do we produce it? But also, what if there's food surplus and some waste streams? What do we do? So my key question was here, if, because the promise of seaweed as a sustainable food source, also protein-rich, alternative food source and to animal proteins, what if we will build a bigger seaweed economy? How can we prevent that we create another wasteful food system? Can we, before we implement or upscale this system, in our regions at least, can we design the waste already out of the system? Can we think beforehand about what might be food surplus effects? How can we use those still and valorize those? And how can we make sure that in total there is zero waste? So what animals or species do we need in the network besides the producers and the consumers to make sure that also the residual streams and the rests are taken care of? And if we cannot find that answer, then maybe we need to think a little bit more before we upscale. And the nice thing is that also this research started with small niche experiments and solutions. So it's not trying to solve everything at once, but it really emphasizes the need to take smaller and quicker actions, prototype it, test it, and then see how that works in the total system. So seaweed was a good. As you know, it absorbs the CO2. It does not need fresh water or land to grow. There's an option of abundance, and it also has a lot of health benefits. And then there was also a research from Wageningen University, research university, that did an experimental thinking exercise. What if we have, according to the plans of the Dutch government, we will implement large seaweed farms on the North Sea, for example, in between windmills or any other way. They calculated that humans, or at least in our society, a Western society, people are not inclined to eat so much seaweed as a whole. I think they did research, and after insects and somebody else, seaweed was the third mentioned not to be an attractive source of protein if you would eat it as vegetables. But that is now, right? So I'm not talking about in the future. I think that might change. But on the current, I said, no, if we're going to produce so much seaweed, then there will a huge surplus. And that also means if that is not used properly, then we'll have a lot of waste. So they did an exercise also. What if we then look at the more functional ingredients of seaweed? What if we take out, for example, the proteins and create it as a functional ingredient for food? That in itself proved not to be a very strong business case. So they did a calculation exercise on what if we do double extraction and we also extract alginate, which can also be used as a binder in food, but also for medical applications, for example, or in the beauty industry. And then still after extraction, if we look at macroweeds at least, 80 to 90% of the plant material would still be there. So that if we take it back to the food web, there would still not be zero waste. So they calculated, of course, we can use it, which is also a good use, to fertilize land, or we can use it for biomass for energy, for example. So, but then the designer, of course, in me woke up and said, okay, so what do I know? Not energy, and I'm also not a farmer. I cannot do something with crops, but I do know materials. So I thought, can we use or valorize then the residual stream after maybe extraction of proteins for food? Can we somehow make good use of the fiber material or the plant material that is left after extraction? And that is how I came to my first idea of the seaweed web. So this is a schematic overview. On the left, you see, of course, the seaweed, which can be eaten above as a whole, as a plant. If not, you can go horizontally and you can extract a food ingredient, for example, proteins, but also, depending on the type of seaweed that you use, agar or alginate. With both, you can make, for example, bioplastics, but you can also have, as I said, you have after extraction left plant material. You can create maybe other biomaterials. Those can be translated into circular designed applications, products. And in the end, the ultimate goal would be to create biocircular products and materials so they can also be, in theory, be put back to sea. So this is again theory. So I had to start practicing. I'm taking a huge leap now. But these are some form experiments that I did with the fiber material. So it started, of course, like all biomaterial designers might recognize, Klaske, with small samples of can we create something with this? How does it respond if I mix it with other fiber material? Is it shapeable into 3D forms? So that was a large exploration. If I create a biopolymer, so if I mix it again with alginate or agar, what happens then? And so learning by doing, I slowly but gradually understood the characteristics of seaweed, and also what still fascinates me is the different types of seaweed that lead to completely different materials, both in mechanical properties, for example, but also aesthetically. So that and that combination in the end will define in what application it's most useful. So these are the fibers, and it slowly moved towards a more stronger material. And here you see also some bioplastic samples, and but you do not see on the image, but we try to also make a biocoating out of it. all seaweed based. So in the end, it will be biodegradable. It's also mixed with terrestrial plant fibers to actually combine the strength of the seaweed with the strength of other known plant materials. Those also are residual streams. So they come from the agricultural waste or the timber, wood industry waste streams, residual streams, or the paper industry. So those wood fibers can be used, and combined they form a rigid wood-like material. And that's also how then the application for this material came to be. And that was for the building industry. Because as I said, I was looking to valorize, can we prototype a system that not only works for food, but also for materials and its applications, and not only green, but also has economic perspective. So it has an opportunity to scale up and maybe have in a completely other sort of food chain, in this case, the housing, living environment of people, have a positive impact. Well, I think you might know that in the Netherlands, at least, we have a huge challenge to build 800,000 to 1 million new houses. But also there's a lot of problems with the not so circular building materials or construction materials. The objective of the new material that we have developed is to have a place in this building chain. So that is, well, I don't know how many of you know the building industry, but it's not the ones that may embrace new materials and difficult thingies the first, but no challenge, no fun. So this is in the end what the material looks like now. So we have different mixes. We have called it Seawood as the new building material from the sea. As somebody else put it nicely, the trees can exhale in happiness now because we have found not something to replace wood, maybe, but to put aside, to support as an extra source, as a regenerative source, as a biocircular source. Now the challenge is to create something that cannot just be used once. We can regrind it after use and form it again, which is mostly pressing. But we're also in communication with the construction companies. What they are also looking for, and I was happy to hear that, is that it cannot only be used once, but ideally you would be able to take it off and put it back in a new building. That requires a lot of testing. We're not there yet. It actually just was first shown at the recent Dutch Design Week as concept for the very first time. Together with all other kinds of interesting biomaterials. So this is the exploded view designed and envisioned by the company New Heroes to again also create something tangible and something imaginable, because if biocircular building is an abstract idea, if people cannot see it, if people cannot touch it or feel it or even smell it in some cases, it's hard to imagine how. So these kinds of installations help to also not only look at it from a technical perspective. Yes, we can make all kinds of interesting materials from biosources. So you see different materials here also made from seaweed, by the way. So on the top in the middle, you see a seaweed as a roof solution. On the left, you see a very nice wall of bioplastics that actually came from the textile industry, but can be also used as wall covering. On the bottom right, you see seaweed panels made by the studio Klarenbeek and Drost. Now, for those of you who were there, they work with Nicky Speel from the Seaweed Farmers. So that is fermented seaweed. And I have a small video, I think, of the Seawood panels that we made. So here it's more of like a blanket. So you see different applications and different mixes of seaweed and other plant materials. Also to show that that it's possible. And then now, of course, the next step is how can we implement that? But we're already really happy. So we see Seawood as a fiber board from seaweed fibers mixed with residual terrestrial plant fibers. The binder comes out of the seaweed itself as well. So that is the third point. We use green chemistry. The MDF in essence is not bad, although they, in some forms, UF is used. More toxic binders or chemical binders, we do not need to use them, which also makes them then in the end recyclable and biodegradable. So we see it as a sustainable alternative, or at least addition to what's available for MDF. So it cannot be used maybe in all circumstances. So this is the material. This is where we're at. So we're looking for, because we're still building. This is still just a material and an application, but then to have real impact and scaling up, there needs to be somebody that wants to use it. So we used to say, okay, if you can do it and you like doing it, but nobody wants it, it's a nice hobby. But we are actually here to create environmental and economic positive impact. So that's why we talk now based with this concept to find partners who are interested in the material, and because as a startup, it's hard to really revolutionize the whole building industry, but together with a more industry partner or somebody else that might work. For those of you that might wonder what happened with the food, we're still working on that as well. Mostly with education, because that's also where I worked for a long time, and I also believe that there's as many new students or professionals. They need to learn, one, the material, B, the green chemistry. So whatever we know, we would like to share and develop together. So these are some examples of a minor food product design, all based on brown seaweed, or at least a little bit of it in it. So on the left, you see nice bars, very healthy with nuts, and they're all vegan, by the way. In the middle, you see instant noodles with a little bit of seaweed touch to it. And on the right, you see those black pickles in the bread are also seaweed. So this is a collaboration with the Hague University of Applied Sciences, where this minor is actually interdisciplinary minor. So there's food and dietetic students, design engineering students, because it really needs to become including packaging, a full food concept, and process and food technology students. So combined, they create a new food concept. So that might be for the food part. Next to that, because now we have the boards, but we also still need to look at the protein extraction. So that is a collaboration also with the process and food technology to see how we can, in a as green as possible process, extract proteins, because we actually do not want to put them in the building material. And we do want to capture CO2 for a long time, but we do not want to lose the nutritional value of seaweed. Also in-house, we do a lot of experimentation on getting the full green extraction process. So that actually has worked already, but we try to optimize it now for upscaling. So we try to reduce also, for example, time on how long it takes to extract the alginate. We actually mostly use nature-friendly chemicals, so that's mostly salts with a little bit of heating, but then you can extract nice sodium alginate out of the seaweed. Because for those who don't know, the alginate is what we are looking for, and it's actually captured in between the cell wands of the seaweed. Well, those need to be broken. You can do that rather roughly with harsh chemicals, but we use a more or we use a friendly way to do that. And we use it also for a natural biocoating. And of course, then the circular and social design, and that focuses more on the social innovation. For most people, biomaterials are quite exotic still. People compare it to traditional materials and they see mostly the downside of it. Together with industrial design students, we also develop then more products that are meant to bring in home. So we literally want to bring seaweed products in the homes of people and in the hearts of people, so that so it becomes actually the new standard to have furniture and all kinds of other products made from biomaterials. And in this case, we work with seaweed, but there are many more interesting materials as well. So we try to break that open as well. And today I had a final presentation of TU Delft students, collaboration with Planet Bio, to actually look at the economic and ecological impact in case of upscaling. So with the processes that we have now, what does it mean in terms of economic impact and ecological impact? So we think we are doing very green, but it's always nice to have that quantified. And it looks very good. We also know where we need to improve. So that was also the starting point of the question. What are the most influential factors on economic impact? So what are the most costly process steps? And what causes the highest ecological impact? And can we still tweak that before upscaling? And then the final conclusion is, okay, we have the seaweed. We are in conversation with a lot of partners to actually form that food web of organizations around seaweed, to do the extraction, to use all the residual material that is left, and to have industry partners that would want to step in to scale up and to create the impact that we aim for. And by doing that, hopefully also contribute to doubling nature by giving the seaweed economy a boost, because there will be an economic incentive as in terms of offerings and market questions. And then I would like to conclude with something that made a big impression on me, because I thought, yes, we try to change people's behavior, and as you know, that's the most difficult thing to do. But if you give something or you create something that just works better and feels better and is better, then I'm very hopeful that we can make that change. Thanks.